Part of the evidence that disputes the Big Bang theory and proves the electric universe is actually located in the Big Bang theory itself. The theory states that the entire universe exploded into being 13.8 billion years ago and has expanded from a single point as a cloud of dust that spread across cosmic space with ever-increasing speed. The proof that the expansion theory is not possible becomes evident in the amazing uniformity of the spectral lines in light from close-by stars compared with the light from most distant galaxies. When light passes through atmospheres of atomic gases, the various elements contained in them resonate at specific frequencies, where they absorb light energy. From the location of the absorption lines, it becomes possible to determine the types of elements contained in the gases, including their ratio. While the energy depletion in the propagation of light from extremely distant galaxies, on the order of hundreds of millions of light years, has caused a redshift in the spectrum resulting from the energy depletion of photons, an amazing uniformity of elementary composition comes to light. The spectral uniformity tells us that all the stars in the universe are enveloped by gases with essentially the same elementary composition, no matter how near, no matter how far they may be located. This uniformity is not possible on a Big Bang basis. When a gas cloud expands for billions of years, it is not possible that its elementary composition is not radically altered as it expands, considering the vast difference in gravitational attraction up to 240 to 1, which exists among the various atomic elements. The resulting composition would have been radically altered during the 13 billion years of the supposed expansion of the dust and gases. The similarity of the elementary composition in distant galaxies with the composition surrounding the stars nearby proves that the atomic elements that caused the similarity were created everywhere locally by each star itself, resulting from the same synthesizing electric fusion, reflecting the same principle, and being expressed in the same process, no matter where the stars would be located in the universe, near or far. This means that plasma alone is the singularity in the equation that we see the result of, which of course is universally abundant, as it is an element of space itself, according to America's most advanced theoretical physicist, David Bohm. For references, see Part 2 of this series. The similarity of the spectral lines also solves the long-standing paradox regarding the CO2 concentration on Earth. Cold fusion evidence in CO2. If the Big Bang composition of the created elements is universally similar, it shouldn't be possible that the Earth has extremely small amounts of CO2 in its atmosphere, while the atmosphere of its neighbor planets is made up almost entirely of CO2. This shouldn't be possible. It is a paradox. The paradox becomes resolved when we recognize that all the carbon and the oxygen for the CO2 in the solar system were synthesized on the Sun from plasma by electric fusion. With this being recognized, the paradox becomes resolved as but a local distribution characteristic. We can see sometimes with our own eyes, on rare occasions, that the atomic elements in the solar system were synthesized on the Sun and flow away from the Sun with the solar wind. We can see the evidence for this in the form of noctilucent clouds that exist as streams of ice crystals flowing high in the stratosphere at an altitude of 80 kilometers. Water vapor, which is heavy, isn't lifted off the ground to such an immensely high altitude. The very fact that its existence is there suggests that the atomic elements that form the water crystals were deposited onto the Earth's outer atmosphere by the solar wind flowing from the Sun. Just as water vapor in the high stratosphere for the noctilucent clouds was deposited into the outer atmosphere of the Earth by the solar winds, so CO2 molecules are deposited there likewise. High concentrations of CO2 have been measured in the stratosphere, in the 600 parts per million range at an altitude of 30 kilometers above the surface. Large concentrations of this heavy gas should not be found at such an extreme altitude, unless the bulk of it came from the Sun, carried by the solar wind. That all the atomic elements of the solar system were synthesized on the surface of the Sun is evident by their distribution of the elements in space around the Sun. Since the heavy elements are not as easily carried along by the solar wind, they are first to fall out. This would result in the forming of heavy planets at close distances to the Sun, which we term the inner planets, ranging from Mercury to Mars. The same can be said of the atmospheres of the planets. The closer the planets are, the heavier their atmosphere is. For this reason, the innermost planet with an atmosphere, which is Venus, has an atmosphere that is made up almost entirely of carbon dioxide, termed CO2, which is a heavy gas with an atomic weight of 44. For this reason, the farthest planet is made up almost entirely of hydrogen gas with an atomic weight of 1. The atmosphere of the Earth is lighter than that of Venus, for reasons of it being further away from the Sun. Our atmosphere is made up of gaseous oxygen with a weight of 16 and nitrogen with a weight of 14. Most of the oxygen near the Earth has been bound up with hydrogen to form water that has a weight of 34. Only a tiny portion of the synthesized carbon atoms, when they became combined with oxygen into carbon dioxide, has made it as far as the Earth. The present CO2 concentration on Earth is a mere 390 parts per million. The average CO2 concentration on Earth is presently at the lowest level it has been during the entire time span of abundant life on our planet. It may have been more than 20 times as dense 500 million years ago, according to a number of major studies. CO2 never stays in the atmosphere for long. 30% of it is recycled every year through the oceans and plants. In the recycling process, much of the CO2 is lost over time, as it remains dissolved in the oceans. Because of the recycling loss, the atmospheric CO2 had reached extremely low levels around 300 million years ago, as we see it here in this simplified diagram. The evidence tells us that the solar fusion synthesis of oxygen and carbon and their flowing in the solar wind is typically insufficient to offset the recycling losses. This deficiency has made life on Earth rather poor during the late Carboniferous period and the early Permian period, until a major CO2 uplift had rescued the biosphere. CO2 is extremely critical for all life on our planet. Plants can't exist without it, and we ourselves cannot exist without the plants that our entire food chain is built on. CO2 is so critical that if the present concentration in the air is cut in half, the plants die, and if it is doubled, a 50% increase in plant growth results. If the CO2 loss had continued past the Permian period, life might have become extinct for the lack of CO2. This didn't happen. Life was rescued by a gigantic solar event that gave life a huge boost. The solar event occurred during a peak period in solar activity. The plasma density was extremely high at the time, which was reflected as a much hotter sun with denser and faster solar winds. What we see measured here reflects the surface temperature of the oceans, measured in variations of a heavy isotope of oxygen in the waters of the oceans. The normal abundance of the heavy oxygen, named O18, is 20 mil, or 20 parts per thousand, or 0.2%. When the sunlight is hotter, the lighter water is more readily evaporated than the heavy water, which changes the abundance ratio at the surface. The ratio is preserved in the calcium shells of microorganisms that live at the surface region of the sea. By examining the accumulations of their remains in sediments, the global climate can be reconstructed for the last 500 million years, as shown here. During the peak period of extreme solar activity in the Permian period, an extremely large event occurred, which evidence suggests would have been an electric discharge event between the Sun and the Earth. The solar wind is basically an electric wind, made up primarily of plasma. Plasma is a near-perfect conductor of electricity. In times of extreme solar wind density, an efficient electric connection between the Earth and the Sun would likely have resulted to cause a type of solar lightning. It may have been a gigantic discharge event of this type that, with electric stress effects, has pulverized much of the mantle of the Earth across a large area of what is presently northern Siberia, enabling enormously large magma flows, which created the flat basalt province termed the Siberian Traps. It is estimated that the flat basalt cover up to 7 million square kilometers of land and contain up to 4 million cubic kilometers of basalt. This single event raised the global CO2 level 5-fold at the time, as you can see here, near the Permian boundary 250 million years ago. For this increase, close to 5 trillion tons of CO2 would have been injected into the Earth's atmosphere. It may be argued that this increase resulted from the volcanism of the Siberian flood basalt event. It is far more likely, however, that this huge increase flowed directly from the Sun, which is surrounded by a heavy gaseous atmosphere and would have been even more surrounded during the hot times. The solar lightning strike may have lasted less than half an hour. Evidence suggests that a similar lightning strike occurred during the Jurassic period. In this case, the gigantic Central Atlantic magmatic province was created, with lightning offshoots across the supercontinent. The event injected another 5 trillion tons of CO2 into the atmosphere. The resulting electric stress induction during the event at the time may have started the breakup of the supercontinent, termed Pangea. And still larger solar discharge event may have produced the enormous CO2 uplift which evidence suggests has occurred in the early Cambrian time, more than 500 million years ago. The existence of an enormous lightning discharge crater has been discovered, located in north-central Australia. It is termed the Massive Australian Precambrian-Cambrian Impact Structure. The huge lightning impact crater was carved 2,000 kilometers wide. Can you imagine the immense type of lightning that creates an impact crater spanning 2,000 kilometers? Actually, several of these exist. A large one of this type exists on the Moon. Another one exists on Mars. The big discharge impact crater on Mars, named Hellas Basin, was carved 23,000 feet deep and 2,300 kilometers across. Events like this would have brought enormous volumes of the heavy CO2 to Mars, which over time became its atmosphere, which is fast fading again. Many ripples are apparent in the measurements for the historic CO2 on Earth. One of these ripples is linked in time with the forming of the Deccan traps in India, which may have resulted from another solar lightning impact, a comparatively small one that caused a flood basalt event extending across a mere 500,000 square kilometers, with an estimated volume of 512,000 cubic kilometers of magma. The event is closely timed with the extinction of the dinosaurs. The resulting volcanism may have blanketed the sky with ash for extended periods that wiped out all food resources. How massively effective a large high-intensity lightning discharge from the Sun can be is evident to some degree by the carving of the Grand Canyon in Arizona. The entire canyon may have been carved in less than 15 minutes as the Earth rotated beneath the discharge from a high-density plasma stream that cuts through rocks and stress fractures them into powder. A similar canyon was cut on Mars in distant time, only much bigger in size. Wells Marineris is a system of canyons 4,000 kilometers long, 200 kilometers wide, and up to 23,000 feet deep. It was likely cut in a single large electric discharge event, in which Mars also gained a large portion of its atmosphere, which is made up almost entirely of CO2. Mars is far too distant from the Sun for the heavy CO2 elements to become carried to it in large volumes by the solar wind. It is safe to say this, considering that the Earth, which is closer to the Sun, doesn't get enough of CO2 from the solar winds to maintain its biosphere. The normal distribution channels evidently carry the CO2 which originated at the Sun not much farther than Venus. The atmosphere of Venus is 96.5% CO2 and 3.5% nitrogen. It appears that the solar lightning is the only efficient transport of heavy gases over long distances in the solar system. The high gas transport efficiency of the solar lightning channel may be the reason why we exist today. Life might have vanished on Earth, except for primitive forms, if it hadn't been for the gigantic lightning events that brought CO2 to our planet and had uplifted our atmosphere repeatedly with the most basic necessities for carbon-based life to exist, which is carbon dioxide, called CO2. Solar lightning is apparently such an efficient long-distance transport channel for heavy gases that it has enabled Saturn's rings to form and its ice moons. Saturn's rings and some of its moons are made up of water ice, which Saturn itself does not have, nor would have because of its distance from the Sun. The existence of Saturn's icy moons and of the great rings made of ice has become possible by the great conveyor belt of solar discharge lightning, which Saturn tends to attract. That solar lightning events are more likely for Saturn than for any of the gas planets reflects the fact that Saturn is the most electrically active planet in the solar system. The cause for it lays beyond the scope of this video, but the fact itself is evident by the strong aurora structures on both of the poles of the planet, which may be the strongest aurora in the solar system. Titan, the largest of Saturn's moons, has, in addition to being an ice moon, a nitrogen atmosphere. The heavy nitrogen gas should not be found there. It does not exist on Saturn. It is most likely carried with a solar discharge event in combination with the water molecules for the Moon itself. While both of the gigantic Permian and Jurassic discharge events caused enormous volcanism and some of the largest ever mass extinctions of life, they produced the great CO2 upramping that gave life a new chance, with enough CO2 into air by then to last for the next 250 million years. Unfortunately, the CO2 on Earth has diminished back to the CO2 starvation level that may be similar to that of the early Permian time, which was a harsh time for life before the second round of the great ramp-up events began. Ironically, it may have been those enormous, sharp uplifts in global CO2 in Permian and Jurassic time, which together gave life another 250 million years to exist, which had caused, as a consequence, 2 huge mass extinction events. CO2 is 28 times more soluble in water than is oxygen. The sharp and sudden increase in CO2 concentration in the air would have massively increased the concentration of CO2 in the oceans. It would have caused ocean acidification beyond what many forms of life could tolerate. The result was, in Permian time, together with other causes, the mass extinction of 95% of all existing species. The observed extinction pattern is consistent with the preferential extinction of heavily calcified species. While many species became extinct thereby, the extinction itself opened the landscape to the development of new species that could utilize the new and more powerful environment for life, which otherwise might not have existed at all, such as the dinosaurs and the mammals afterwards that we became a part of. It is critical for us to realize that the normal solar induction of CO2 in the Earth's atmosphere by the solar wind is insufficient to maintain life on our planet, especially during ice age conditions, when no influx from the inactive sun occurs, and when greater amounts of it are absorbed by the oceans in the colder climate. Ice core samples tell us that during ice age conditions, the CO2 concentration in the air may drop to such low levels that plant growth potentially stops. Plant will even die when the concentration falls below the 150 parts per million level. The Earth might have come close to that during the last ice age. The three big discharge events that ramped up the global CO2 won't be repeated anytime soon, probably not for another 100 million years. The electric density no longer exists at the present time for this to be possible. Our galaxy is presently at the weakest state it has been in 440 million years. Because CO2 has diminished after each ramp-up, it presently stands at a biological starvation level. This means that we need to up-ramp the CO2 concentration ourselves this time, not by getting more CO2 from the sun as before, but by getting substantial amounts out of the great storehouse of CO2 on Earth that the oceans have become. Knowing all this will hopefully inspire us to uplift the global CO2 concentration by pumping some of the stored up CO2 back out of the oceans. That's easily done. Close to 40 trillion tons of CO2 is stored in deep ocean waters, dissolved under pressure. It is a simple process to liberate 5 trillion tons of it from the deep oceans by simply lifting the water to the surface. With the pressure removed, the CO2 degasifies, like with the opening of a soft drink can. When the degassing forms bubbles, the resulting lighter weight of the water column should drive the entire degassing process all by itself once it is started. So it is that an intelligent understanding of the sun and its dynamics can inspire us to build the required infrastructures that are needed to support life on our planet, which becomes extremely critical during the next ice age.